Hi everyone, this is Mrs. J, and today we're going to learn about arithmetic sequences and series. So an arithmetic sequence is a sequence that can be written in this form. So A plus D, A plus 2D, A plus 3D. So you'll notice that each time from here to here I'm adding D, and then from here to here I'm adding another D, and from here to here I'm adding another D. So this is really just a fancy way of saying that there is what's called a common difference between each term. So meaning you're adding or subtracting the same thing every single time. So in this example, A is the first term, and then D is what's called that common difference. And again, you can be adding, so the common difference can be positive, or you could be subtracting, so it could be negative. So there is a formula that we can use to help us write an arithmetic sequence. So the nth term of an arithmetic sequence can be given by a sub n equals a sub 1, the first term, plus n minus 1 times d, that common difference. So all you need to know are the first term and the common difference, and then you can write the arithmetic sequence. Okay, let's give this first one a try together. It says find the first 6 terms and the 300th term of the arithmetic sequence 13, 7, so on, so forth. So we can see here that it states that it's arithmetic, which means we're going to be adding or subtracting the same thing each time. And then we can see here that the common difference is -6. So we could really easily just continue that pattern and list out the first 6 terms. So we have 13, 7, 1, -5, -11, and -17. However, if we want to find the 300th term, it would take us a really, really long time for us to list it out to that point. So for when we have something like this, we're actually going to want to make the formula for that sequence. So again, we're going to be using the formula a sub n equals a sub 1 plus n minus 1 times d. And in this case, we know that a sub 1 is 13. We're told that the common difference is 13. Or sorry, the first term is 13, and we know that our common difference is -6. So we simply plug it in. So a sub n equals 13 plus n minus 1 times -6. And I usually like to rewrite this. I like to distribute and combine like terms here. So a sub n equals -6n plus 19. So it's just a little bit easier for us to work with. So again, this is our formula. So using the formula, we could really easily find that 300th term. So it's just going to be -6 times 300 plus 19. So the 300th term is -1781. And there you have it. So again, anytime you're asked to find the nth term of a sequence and it's too far away to just simply list it out, just make the formula of the sequence and then you can find any term that you want. Okay, let's try another example together. So here it says if the 11th term of an arithmetic sequence is 52 and the 19th term is 92, find the 100th term. So we are going to want to create an equation or the formula so we can find that 100th term. However, remember there's 2 things that we need to find the formula. We need the common difference and the first term. And with the information given, we are going to need to find those first. So luckily, we have 2 pieces of information which we can use to set up a system to find 2 pieces of missing information. So when they say that the 11th term of a sequence, of an arithmetic sequence is 52, they're saying that a sub 11 is 52. And when they say that the 19th term is 92, they're saying that a sub 19 is 92. So we're going to plug these values into this formula to set up a system. So again, here we put what the term is. So here we would put 52, which is the 11th term, equals a sub 1, which we don't know, plus n would be 11 in this case because, again, it's the 11th term. So 11 minus 1 times d, which we don't know. And then for the second piece of information, again, the term is 92, and that's the 19th term, so that's for our n value. 19 minus 1 times d. So now we have a system of equations that we can solve for. So I'm going to multiply equation 1 by negative 1. So we have negative 52 equals negative a sub 1 minus 10d. And then we're going to add that to equation 2. So here you can see that our a sub 1 terms cancel out, and we're left with 40 equals 8d. So we know that d equals 5, which is one of the pieces we needed. And now we can plug that in to either of our two equations. So I'll plug it into equation 1, 52 equals a sub 1 plus 10 times 5. So a sub 1 equals 2. And now that we have those two pieces of information, we can make our formula. So a sub 1 equals a sub n equals a sub 1 plus n minus 1 times the common difference, which is 5. And I like to rewrite that as 5n minus 3. So this we can use to help us find the 100th term. So we just simply plug in n equals 100. So 5 times 100 minus 3. So we can see that the 100th term is going to be 497. All right, so at this point, I'm going to ask you to pause the video and give this example a try, and we'll check your answers in just a few seconds. Okay, so go ahead and check here. So again, we were told that the 11th term is 63 and the 15th term is 87. So I substituted n and a sub n into our formula 2 times to make these two equations. And since we have two equations, we can solve the system for two variables. So here you can see I first solved for d, substituted and solved for a sub 1, which you can then plug back in to your formula, and then that allows you to find the 800th term, which would be 4,797. All right, so the next thing we're going to talk about is how to find a partial sum of an arithmetic sequence. So remember, partial sum would be the sum of the first however many terms of your sequence. So the nth partial sum of an arithmetic sequence can be found using one of these two formulas. So here we have s sub n equals n over 2 times 2 times a sub 1, your first term, plus n minus 1 times d, or common difference. Or the one that I really prefer using, this is the more common form that you'll see, is s sub n equals n times a sub 1 plus a sub n over 2. So really this is just a different form of this first equation. So I am going to be using exclusively this term, or this formula. So to use this formula, a few things you need. You need to know the first term and the last term of the nth partial sum that you're finding. And then you just plug those in to the formula and you should be good to go. Okay, so here we are asked to find the sum of the first 40 terms of the arithmetic sequence 3, 7, 11, 15, so on and so forth. So again, we're going to be using this formula, s sub n equals n times a sub 1 plus a sub n over 2. So a few things we know. Well, we know that n is 40 because it's the sum of the first 40 terms. We are given that our first term is 3. I can see that listed here, but we do need to find that last term, our 40th term. And we can find that really quickly by creating our formula for this sequence and then plugging in to find the 40th term. So I can see here that we do have a common difference of 4. So we can say a sub n equals 3 plus n minus 1 times 4. So this would be our formula, and we can rewrite that as 4n minus 1. And then we can really easily use this to help us find the 40th term of our sequence. So the 40th term would be 4 times 40 minus 1, which is 159. So that's a missing piece of information, and now we have everything we need to find our sum. So the sum of the first 40 terms is n, which is 40, times a sub 1 plus a sub n all over 2. So that should give us an answer of 3,240. All right, here we are asked to find the sum of the first 50 odd numbers. So here we know that we're going to need to create the formula for the sequence that describes odd numbers. So if it helps, you can kind of list them out. So we know that odd numbers, they have a common difference of 2, and we know that the first term is 1. So we can say a sub n equals 1 plus n minus 1 times 2. So a sub 1 equals 2n minus 1. So that's a formula that describes all of the odd numbers. So we can use that to help us find the 50th term. So 2 times 50 minus 1 is 99. So now we have everything we need for this formula to find the sum of the first n terms, which is n times a sub 1 plus a sub n all over 2. So the sum of the first 50 odd numbers is 50 times 1 plus 99 over 2, which gives us 2,500. All right, so at this point, I'm going to ask you to pause the video and see if you can find the sum of the first 40 terms of this arithmetic sequence, 3, 10, 17, 24, etc. Okay, let's check your answers here. So you can see the first thing that I did was I found the formula for that sequence, which is described as this, and that allowed us to find the 40th term, which is 276. So the sum of the first 40 terms is 40 times the first term 3 plus the last term 276 over 2, should give you 5,580. Okay, so now we're going to try to work our way backwards. So this says, how many terms of the arithmetic sequence 5, 7, 9, so on and so forth, must be added to get 572. So again, we're going to be using this formula. But working backwards. So let's go through this one variable at a time. So we know that the sum is going to be 572, so that's something we know. We are trying to find how many terms, so that's going to say n. Here, we do know that the first term is 5, but we don't know what the last term is. We don't know a sub n, and we don't want to create a second variable. So we know that we can actually rewrite a sub n as a sub 1 plus n minus 1 times d, right? So this is our formula for a sub n. It can always be replaced with that formula. And then these values we do know. We know that a sub 1 again is 5. So let's substitute 5 again. And then we don't know n here, but we can see in the sequence that the common difference is 2. And all over 2. So this should allow us to solve for n. So here we can distribute and combine like terms. So we have n times 2n plus 8 over 2. So 572 equals, so if I divide both of these by 2 and then distribute the n, we get n squared plus 4n. And then you can see here that we actually have a quadratic equation. So we are going to need to set our equation equal to 0. And we can solve this in a number of different ways. This one just so happens to be factorable, so that's definitely the method that I'm going to pick. So it's n minus 22 times n plus 26, so that gives us two answers to look at least. So we get n equals 22 or n equals negative 26. So here, it doesn't really make sense to have a negative n value because it says how many terms. It's impossible to have negative 26 terms. So that means that 22, positive 22 is our only answer. So 22 terms. Again, the key here was recognizing that we don't want to create that second variable of a sub n. So we're actually going to replace it using the formula for an arithmetic sequence. A sub n equals a sub 1 plus n minus 1 times d, right there, because that has two values that we do know, a sub 1 and a common difference. All right, so now we're going to move on to more of a word problem. So this says an amphitheater has 50 rows of seats with 30 seats in the first row, 32 seats in the second row, 34 in the third, and so on. Find the total number of seats. So when they say the total number of seats, really they're asking us to find the sum of the first 50 rows in this amphitheater. So first we need to find a way to describe the sequence that's going on. It is arithmetic because you can see each time they're adding 2 seats. So we could say a sub n equals 30 because there's 30 seats in the first row plus n minus 1 times 2, which is the common difference. So a sub n is 2n plus 28, so that's the sequence that represents the number of seats in each row. So that means that we can use this to find out how many rows or how many seats are in the 50th row. So there are 128 seats in the 50th row. So now we can find the sum of the first 50 rows by doing 50 times a sub 1, which is 30, plus a sub n, which is 128, all over 2. And we should get an answer of 3,950. So 3,950 seats. All right, so here's the last problem. Go ahead and pause the video and see if you can give this one a try. All right, let's check here. So this is an arithmetic sequence because it says each year he's getting a raise of $3,400. So you can create the formula by saying 75,000 plus n minus 1 times 3,400. And this allows us to find the 10th term, which is $105,600. So that's how much he makes in his 10th year. But they want the total money he makes over the first 10 years. So they're asking you to find the sum of the first 10 terms of your sequence. So it's important to understand that this is a sum problem, not just simply finding how much he made in his 10th year alone. So we do 10 times a sub 1 plus a sub n over 2, and you should get $903,000. All right, that is all for today's video. Thank you so much for watching.